Class, in this video, we are going to learn the very basics of something that you'll hear referred to throughout high school in math, and it's called SOH-CAH-TOA. And you will hear math teachers and students talk about SOH-CAH-TOA, and all I'm wanting to do in this video is to help you understand what in the world we are talking about when we use a phrase like SOH-CAH-TOA. What in the world's going on here? And so basically, I want us to start off with understanding that we're dealing with right triangles only. What I'm about to show you only applies to right triangles, and that means angles with, of course, a 90 degree. Now we're going to start off with a basic right triangle, and you can see that I've labeled each of the corners, each vertex of this triangle with a capital letter. Anytime we deal with capital letters we're dealing with the angles. All right, lowercase letters would be more of a side length. So this would be like lowercase a, lowercase b, and a small c. Those deal with side lengths. You don't need that necessarily for this, but it's very important when we deal with math language to understand what in the world we are talking about. So let's go back up here to the top, and let's focus on the S, the C, and the T. The S is for sine. Now there's abbreviations. There's 3-letter abbreviations that we're going to use, but this is sine, and this is cosine, and that is tangent. Now the way you will see them written is like this, without the parentheses: sine, cosine, and tangent. If you have a scientific calculator, you have seen it's not the sin button, it is the sine button, the cosine and tangent. Now what are these? Now the sine, it's about a ratio. So if we were to say, what is the sine of A? Now this A is that A, the sine of angle A. Well, what it is the ratio of the opposite side to the hypotenuse. Opposite, hypotenuse. Well, what if I wanted to do the cosine of A? Well, that is the ratio of the adjacent side to the hypotenuse. Now look, this is, if you've never seen this before, this is not supposed to make very much sense just yet, so hang in there with me. But there's your adjacent, and there's your hypotenuse. Now what if I wanted to take the tangent of A? That is going to be the ratio of the opposite side length to the adjacent side length. So there is opposite, and there is the adjacent. So SOH-CAH-TOA, what does it stand for? That the sine, put my cursor in here, the sine is equal to the opposite over the hypotenuse. There's your SOH-CAH. Cosine of an angle is adjacent over hypotenuse. TOA, tangent, is equal to opposite over adjacent. Now when I was a senior in high school, and you got to remember that we are down in the South here, my trig teacher said, some old hen caught another hen taking oats away. Now, I've had a couple of students over the years like that one. Most just look at me and roll their eyes and say, that's really dumb. Hey, but I graduated high school a long time ago, and I still remember that. So, hey, maybe it's not so dumb. But SOH-CAH-TOA, some old hen caught another hen taking oats away. Take your pick. Let's go back to our triangle here. And so if I'm talking about angle A, what is the opposite? Let's change colors. The opposite is across from the angle. So the opposite of A is directly across. The adjacent is the one that's directly close to it, all right? But it's not the hypotenuse. The hypotenuse, if I can spell that correctly, the hypotenuse is always across from the largest angle. With a right triangle, the largest angle has to be the 90-degree angle. So the hypotenuse is always directly across from the right angle. And so that would be the hypotenuse. So again, if we come here and look at the sine of A is equal to opposite over the hypotenuse. Now we'll put some numbers on this in just a moment. The cosine of A is going to be the adjacent side divided by the hypotenuse. So if I were to use my letters, the cosine of A would be B over C. Let's go back and do that here. The sine of A would be A over C. this A over C. So the tangent of A would be opposite over adjacent, or A over B. Now we're just using some letters to try to get a feel for what in the world we're doing. All right, now I promise you there's a lot more that we can do with this that you'll be doing in Algebra 1 and Algebra 2, geometry, pre-calculus. This never goes away. I know if you have me in class, you hear me say that a lot through pre-algebra, that this never goes away. This is not one of those concepts that you can just say, well, I'll get through it and then move on. No. This you have to master. Okay, so these are the absolute basics of it. Let's scroll down here and let's do a little practice. Let's do an example. Let's put some numbers on it. Let me draw a simple triangle here. We're going to draw a very simple right triangle, A, B, and C. That is a right triangle. And we're going to use a basic, very standard special right triangle, 3, 4, 5. All right, and we know that the Pythagorean's theorem, which we've already learned, we know this is a right triangle using Pythagorean's theorem. So what if I wanted to say, well, what is the sine of A? What is the sine of A? What is the cosine of A? And what is the tangent of A? This would be a great quiz or a test question. All right, what is the sine of A? Well, I know that the sine of A, because I know SOH-CAH-TOA, the sine of an angle, we'll call it A, is the opposite over hypotenuse. That the cosine of an angle is adjacent over hypotenuse, and the tangent of an angle is opposite over adjacent. Remember taking oats away? All right. Look, this is what you have to put to memory. It's not optional. You have to put this to memory. This is SOH-CAH-TOA right here. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Can't say it enough. You have to put it to memory. So that the sine of A is going to be opposite over hypotenuse, or 4/5. The cosine of A is going to be adjacent over hypotenuse, or 3/5. The tangent of A is going to be opposite over adjacent. Now let's change colors. What if we wanted to use a different angle? What if I said, what's the sine? Let me do this a little, well, I'll go ahead and do it this way. What is the sine of B? What is the cosine of B? And what is the tangent of B? Well, now I'm working with this angle. So, but I know that the sine is opposite over hypotenuse. So, but the opposite of B is the 3. So that's going to be 3. The hypotenuse is the same. Now, what about the cosine of B? Well, the adjacent to the B is 4. So the cosine of B is going to be 4/5. The tangent of B is opposite over adjacent, or 3/4. Now look what happened. The sine in this triangle, the sine of A is equal to, well, it looks like I lost my 5 there. There we go. The sine of A is equal to the cosine of B. All right, and we're dealing with the same triangle here. You'll notice the same thing with the cosine of A and the sine of B. So that's just another pattern that you can look for in math. You're going to see these patterns play out with these triangles. I'm going to give you one more example to try on your own, but this is the absolute basics of SOH-CAH-TOA. All right, here it is right here. This is what you got to put to memory. The sine of an angle is equal to opposite over hypotenuse. Cosine adjacent over hypotenuse, and the tangent equals opposite over adjacent. Let me give you one more. And after I write this down, I want you to pause the video and try it on your own. We're going to draw a very basic right triangle. This is one of our special right triangles. We're going to say A, B, and C. And this is a 5, 12, 13. You can use Pythagorean's theorem. And to prove that if you like, the sine of A, cosine of A, tangent of A, and then I want you to do the sine of B, the cosine of B, and the tangent of B. So I want you to go ahead and pause the video and give this a shot. All right, well, hopefully you have done that. The sine of A is going to be the opposite over the hypotenuse. So that's going to be 12 over 13. The cosine of A will be adjacent over hypotenuse, or 5 over 13. The tangent of A is opposite over adjacent. Now remember, that is the opposite to A. That would be out there, and this would be the adjacent. What about the sine of B? The sine of B, we have to go to the opposite, and that's going to be 5. The opposite of B is 5, and the hypotenuse is still 13. 12 is going to be the adjacent angle, or adjacent side to angle B. Hypotenuse is still 13. Tangent of B is taking oats away, right? So it's opposite over adjacent, and that will be 5/12ths, excuse me. Notice the similarity here, right? The pattern. But also, I didn't point this out a moment ago. Those are reciprocals, all right? That's going to happen. Those are reciprocals. All right, students, I hope this helps. Again, it is a very basic introduction to the SOH-CAH-TOA, but you've got to put that to memory. Here it is, one last time. SOH-CAH-TOA. Some old hen caught another hen, taking oats away. But this is, let me put my cursor on there. This is the sine is equal to opposite over hypotenuse. The cosine of an angle is adjacent over hypotenuse. Tangent of an angle is opposite over adjacent. So sine, cosine, and tangent, how do we define them? They are ratios of side lengths of right triangles only. This does not work for non-right triangles. That's something different. We learn that later. For right triangles only. Hope this helps, guys.